Elimination reactions. Elimination reactions. Here we will discuss the beta elimination reaction. What are the beta elimination reactions? These are those reactions in which two atoms or groups directly attached to the carbon atom in the substrate molecules are eliminated to form multiple bonds. These are called elimination reaction or the beta elimination reaction. Dehydrohalogenation of alkyl halide is is an example of beta elimination reaction. It occurs in presence of alcoholic potassium hydroxide. And as a result, from the one carbon halide, from the alpha carbon halide is removed, and from the beta hydrogen is removed. Why it is called beta elimination reaction? Remember that the carbon atom directly bonded to the halogen atom is called alpha carbon. You can see here, this is halogen, so it is directly attached to this carbon. So this is the alpha carbon, and this is beta, and then gamma, and then delta. And it is true for any functional group, not only for halide. The carbon atom that is directly bonded to functional group is called alpha carbon, and next to the alpha is beta, gamma, delta, and so on. For example, if the compound is like this, for example, this is 2-chlorobutane. So in this 2-chlorobutane, this is the alpha carbon, and both of these are the beta carbon, and next to beta is gamma carbon. So what happens in this reaction? In this reaction, hydrogen is removed from the beta carbon while halogen is removed from the alpha carbon. That's why it is called beta elimination reaction. The hydrogen atom bonded to beta carbon are called beta hydrogen, as I have already told you. Beta hydrogen atoms are slightly acidic in nature due to the high electronegativity of halogen atom. Because halogen has tendency to pull electron, it can withdraw the electron. That's why this hydrogen becomes more acidic. If there is a strong base in the medium, it can remove one of the beta hydrogen. The removal of beta hydrogen atom makes it easy to remove the halide. Halide is not removed earlier. Halide is removed after the elimination of the beta hydrogen. This simultaneous removal of beta hydrogen and halide creates a double bond in the molecule. For example, if halogen is removed from here and hydrogen from here, then a double bond can be created here. Now see the general reaction for this beta elimination reaction. So you can see here that a strong base, it should be a strong base, attacks on the beta hydrogen of the molecule, and as a result this bond shifted to here and halogen has to leave. You can see here. So a multiple bond, a double bond is generated and halide has been removed while it combines with base to form its respective conjugate acid. On the basis of mechanism, beta elimination reactions are classified into two groups or into two types. One is the E1 mechanism and another one is the E2 mechanism. It is just like the SN1 and SN2 as you have seen. So E1 mechanism is the unimolecular elimination reaction. Why it is unimolecular? Because in these reactions, the rate of reaction depends on the concentration of only one reactant, that is the alkyl halide. The reaction is first order kinetics and designated as E1. It is a two-step reaction just like the SN1 reaction, but there was the nucleophilic substitution, and here there is an elimination. Dehydrohalogenation of tertiary alkyl halide follows E1 mechanism. The elimination of halide from alpha carbon and hydrogen from the beta carbon is the best example of this reaction, and you can see this reaction. So hydrogen can be removed from any one of the hydrogen because all of them are beta hydrogen. And then halogen will be removed from here. This is the 2-bromomethyl propane or tertiary butyl bromide. And in short, you can write it tert butyl bromide. And the resulting alkene is 2-methyl propene, because you can take any site as a basic chain, either from this or you can take this is the basic chain. So methyl group would be there on the second carbon. Now see the mechanism of E1 reaction. In tertiary alkyl halide, due to the bulky size of alkyl radical, there is an inductive effect. That is the electron withdrawing effect, that gives the stability to resulting carbonium ion. So you can see here, first the halide is removed automatically, and then a carbocation is formed. And if carbocation is stable, as in case of tertiary alkyl halide, this tertiary carbocation is stable. So in the next step, hydrogen is also removed. And for removal of hydrogen, there should be a base. So base abstract the proton from there. It forms the water. Then bond shifted to there. And as a result, respective alkene is formed. So this is the mechanism of E1 or the unimolecular elimination reaction. This step is the slow step, and it is the rate determining step. Always remember that if a reaction comprises multiple steps, then the slowest step is considered as the rate determining step. And in this rate determining step, only one of the molecule, that is alkyl halide, is present. That's why it is unimolecular reaction. That's why it is called E1 reaction. And this is the fast reaction. Kinetics of the reaction, as I have told you, that this is a unimolecular reaction and rate directly proportional to alkyl halide only. It depends only on alkyl halide. And when you remove the sign of proportionality, there would be the rate constant. And this is the energy profile diagram, in which you can see that here first here is the potential energy, and here is the progress of the reaction. This is your substrate molecule, and the bond is being broken. This is the first transition state, and this is the intermediate, this valley. This is called intermediate because it can be recognized by certain techniques, analytical techniques in the chemistry. And there is the second transition state where this bond is going to be formed, and this bond is going to be broken, and this bond is also going to be formed. यानी ये बॉन्ड बन रहा है, ये बॉन्ड ब्रेक हो रहा है, ये बॉन्ड बन रहा है, एंड एज अ रिजल्ट आपके पास ये मॉलिक्यूल जो है डेवलप हो गया, जो आपका रिस्पेक्टिव अल्कीन है, और साथ में डेफिनेटली वाटर भी होगा. So characteristics of E1 mechanism, it is the two-step reaction. Reaction does not involve the formation of transition complex. ट्रांजिशन कॉम्प्लेक्स तो बन रहा है, लेकिन ये ट्रांजिशन कॉम्प्लेक्स, ये ट्रांजिशन स्टेट है उसकी, वो ट्रांजिशन कॉम्प्लेक्स नहीं बन रहा है कि जनाब वो अटैकिंग बेस और जो है लीविंग हैलाइड एक साथ एक उसमें सिस्टम में मौजूद हो, ऐसा ट्रांजिशन कॉम्प्लेक्स नहीं बनता, जो कि अभी आप E2 मैकेनिज्म में देखेंगे वहां बनेगा ये। Because of successive steps of bond breaking and bond shifting, it involves ionization. Yes, you can see here carbocation is formed. Rate of reaction depends only upon the molar concentration of alkyl halide. Now see the E2 mechanism. E2 mechanism, E2 stands for bimolecular. So this is the bimolecular reaction. Here, the first hydrogen is attacked by the by the strong base. Uh, in E2 mechanism, the deprotonation from the beta carbon and elimination of halogen from the alpha carbon occurs simultaneously. यहाँ पे steps नहीं होगा, यहाँ पे कोई intermediate नहीं होगा. No intermediate is formed. As the abstraction of proton, yani removal of proton from the beta carbon and the expulsion of halide and removal of halide from alpha carbon occurs simultaneously. Thus, base attacks the beta hydrogen, which is opposite to the leaving halide. Opposite होना चाहिए उसे. Now see, this is halide and this is hydrogen. This is also hydrogen. अब यहाँ पर इस halide के साथ यही वाला हाइड्रोजन रिमूव होगा, ये हाइड्रोजन रिमूव नहीं हो सकता. सेम डायरेक्शन, इसका अपोजिट होना, ट्रांस होना जरूरी है. So any hydrogen that is trans to the bromine, it can be removed. Trans to the halide can be removed. Now see, the base will attack on this hydrogen, beta hydrogen, और कौन सा beta hydrogen जो कि उसे ट्रांसपोजिशन पर होगा. And as a result, a transition state is developed that this bond becomes weakened and going to be broken. A bond is forming here, and this bond is also breaking, and a bond between OH and H is being formed. So this is the transition state, and ultimately it will form water. It will be removed as bromidine, and a double bond will be generated here. You can see this is the mechanism for E2 reaction. Kinetic of the reaction, this is bimolecular reaction. Its rate depends on alkyl halide as well as the base. When you remove the sign of proportionality, then there would be the rate constant. And this is as it is because it depends on both the concentration of both the alkyl halide and base. Energy profile diagram, you can see here is a transition state where we can show the attack of the base on the beta hydrogen and simultaneous removal of the halogen. It is one step reaction, and you can see here in single step it happens. Reaction involves the formation of transition complex because of simultaneous deprotonation and breaking of carbon hydrogen bond. This is the transition state that you have seen in previous slide. No intermediate is formed. There is no intermediate. In this stage, you cannot recognize the species. So this is not the intermediate. This is the transition state. It does not involve ionization. No ionization is there. Rate of reaction depends upon molar concentration of both the alkyl halide and the base. So that's all for elimination reaction. In the next slide, we will see the competition between elimination and the nucleophilic substitution reaction.